I'm back again in this video with the Ender 3 Max, and in a previous video I showed you guys how to do the Dual Z upgrade kit on this machine, and in this video I have an exciting new hot end and extruder upgrade for you guys where I've designed all of the adapter parts. Now, to my knowledge, I've not seen this combination on the Ender 3 Max before, so I think it's new, and that would be the combination of the Bondtech LGX Lite extruder combined with the Slice Engineering Mosquito Magnum hot end. And this has become one of my favorite combinations because of its high flow capabilities, and I want to utilize that high flow on the Ender 3 Max to make more efficient use of its large build volume. And this video would not have been made possible without the generous sponsorship from both Bondtech and Slice Engineering. So Bondtech donated the LGX Lite and Slice Engineering donated the Mosquito Magnum hot end for me to experiment with on the Ender 3 Max and bring this content and video and design to you guys. Now, if you guys are looking to do this upgrade on your Ender 3 Max, as with all of my videos, do not forget to check the video description down below. And that's where I put links to all of the products that I use in my videos, as well as links to design files if I'm offering those for free, or links to my website if I'm offering those upgrades available for purchase. So go check that out. And the rest of the video, I'm gonna be walking you guys through how to do this installation. And of course, at the end, we're gonna do some test prints. So let's get started. Let's first take a look at the design and see what we're aiming for. So up at the top, you can see the Bondtech LGX Lite mounted to the Ender 3 Max X carriage bracket. And that bracket is unique to the Ender 3 Max. It's not the same as what you'll find on a regular Ender 3. On the sides, you'll see that I've reused the dual 4010 part cooling fans, and in behind the fan shroud and axial fan, you'll see the Slice Engineering Mosquito Magnum with its mounting bracket. And if you guys plan on using a CR Touch or BL Touch like I do in this video, I've created a bracket for that so that you will have the correct probe offset and you won't have to change it in the firmware. Now we can start the disassembly on our machine, and the first thing we need to do is remove the fan shroud. So there are two M3 button head cap screws up at the top of the fan shroud. You're going to remove those and the entire shroud will come off. Beneath that, you'll find two more M3 button head cap screws holding the extruder heatsink to the X carriage bracket, and those you will remove as well. We are going to be reusing all of the fans in this assembly, but we do need to remove them from the original fan shroud. And to do that, the two part cooling fans on the side are attached with four M2 socket head cap screws. So remove those and the fans will come off. And you'll notice that there are two part cooling nozzles, one for each of the part cooling fans. Those we will not be reusing, so you can just discard those. During this disassembly process, just be careful with the wires on these fans. The wires themselves are quite small and their connections are sometimes a little bit delicate. You do not want to damage them. You're going to repeat this process for the other part cooling fan, and then in behind the heatsink for the extruder, you'll find the extruder fan, which is just an axial fan held in there with four more button head cap screws. Go ahead and remove those, and then everything should be free from the fan shroud, and you can just get rid of that fan shroud because we won't be needing it anymore. Now you can use your side cutters to cut away any zip ties holding the wiring harness and the Bowden tube together. Then you can remove the Bowden tube from the extruder assembly on the X gantry, and then you're ready to remove the heater cartridge and the thermistor from the hot end. To do that, you're going to need a hex key and loosen off the grub screw on the bottom of the heater block. And then you're going to need a Phillips head screwdriver and remove the retaining screw that retains the thermistor in the heater block, and both of those things should pull right out. Then take your old hot end and throw it in a box, telling yourself that you might need it one day, let it sit there for 5 years, and then after 5 years throw it in the garbage, and then find out the very next day that you do in fact need it. Now we can start to strip down some of the parts off of the original Bowden tube extruder setup, and you can start by disconnecting the stepper motor on the extruder, and then you can start loosening off the tensioning screw from the tensioning arm. At the back of the tensioning arm, there should be an M3 socket head cap screw that is the pivot point for this arm. Completely remove this screw, and then the tensioning arm should be able to be removed from this entire extruder assembly. There are three more M3 screws holding the stepper motor to this bracket, and you're going to want to keep your hand underneath the stepper motor while you remove these screws, because there is this mysterious thing called gravity that will cause the stepper motor to fall and smash your glass build plate if you don't catch it once the last screw is removed. Then you can reinstall the original filament guide plate, and those three screws will be reused, but you will need three M3 nylon locking nuts to attach this plate since you're not reusing the motor. Now, if you get this kit from me, I will include that hardware for you. Then we're going to need to gain access to the main board in order to unplug the original thermistor and hot end, and to do that, we go to the top of the enclosure of the main board and remove this single M3 screw. There are 3 more button head cap screws on the bottom cover, and to gain access to those, you will have to carefully tip your machine onto its side, remove these 3 screws, and the cover should come off. Do not violently pull the cover off, as the main board cooling fan is still attached to this cover by its wires. Up at the top of the main board, you'll see some screw terminals, and the ones on the left hand side with 2 red wires leading into them are for the heater cartridge. Loosen off these screw terminals and the ends of the wires should easily pop out. And then on the left hand side of the board, you'll find a connector, and there might be some hot glue holding it in place. You're going to have to carefully remove some of that hot glue, and the connector for the thermistor should just pull right out pretty easily. I'm going to be fishing these wires out of the wiring harness because we are going to be replacing them. And so I'm going to carefully cut away some of the zip ties and then remove some of this wiring harness tape so that I can get those wires to pull out of the wire sheathing. Personally, what I find works best for me is depinning the connector on the thermistor, and then you pretty much just have 2 bare wires, and you can pull the wires right out of the wiring harness out the direction of the hot end. Next, we can take a look at the beautiful new equipment from Bondtech and Slice Engineering. So in this hard shell case, you'll find the Mosquito Magnum hot end combined with some zesty lollipops, some installation hardware, as well as some installation tools. They also sent me this boron nitride thermal paste, which I've used in the past and I would highly recommend. And in this build, we're going to be shooting for more volumetric flow, so we're going to need more heat, and I'm upgrading to a 50-watt heater cartridge. They also sent me the silicone boot for the Mosquito Magnum hot end, as well as a 0.6mm vanadium nozzle, and these are my favorite. I've pumped tons of carbon fiber PETG through these on a Ender 7 build, and I've never had one wear out. In the first box from Bondtech, we'll find the LGX Lite extruder, and you'll notice that there is no motor attached to this one. And these extruders take the pancake style motors, and that's what we're going to find in the second box. So this is an LDO motor in the second box compatible with the LGX Lite. They include the datasheet for the motor, which will come in handy later if we have to swap any of the pins on the connector to get the extruder to turn the right way with the Creality wiring. Now to address the thermistor, what I have here is a cartridge style thermistor. So we have to switch from the Creality bead style to this cartridge style, and that's going to fit inside of the Mosquito Magnum hot end. And to make our lives as easy as possible so we do not have to do a custom firmware build with a new thermistor table, what I have here is the Semitec 104 GT thermistor. From my research, its temperature table is very close to the standard Creality bead style thermistor, and therefore in the temperature range of PLA, ABS, PETG, and other common materials, we may only be a degree or 2 off in the true temperature, which is pretty easy to live with. I'll put a link to this part in the video description down below, and the one that I have here has a Molex Microfit 3.0 connector on the end. Unfortunately, the wires on the other end were too short for the Ender 3 Max, and so what I'm going to do here is I'm going to reuse the wiring from the original thermistor. I'm basically just going to cut those wires and crimp on new terminals for the mating connector for the other end of this Molex 3.0 Microfit connector. I'll put a link in the top right hand corner of the screen to a previous video that I've made about crimping JST style terminals with a pretty generic crimping tool like this one. And the same concept and tool can be applied to these Molex style terminals. So go check out that video if you want to learn how to do that, but the end result is having these 2 terminals on the end of the original thermistor wires that will just clip into place inside of the new Molex connector. Now we can plug it into the thermistor, and the other end still has the JST connector on it, which will mate with the main board. Now I'm going to push the thermistor and heater cartridge wires through the wire sheathing, and we're going to go from the hot end side back to the main board. And you'll see that I've wrapped the connector ends in some electrical tape, and that's in hopes of preventing those connectors from getting snagged on that wire sheathing. Once the wires exit out the other end, then you can take the electrical tape off and we can remake our connections onto the main board. Both of these components are basically just resistive elements and therefore have no polarity. Therefore, it won't matter which way you've repinned your thermistor connector, and the 2 free ferrules that go back into the screw terminals for your heater cartridge. You can put them back in any order. If you have a hot glue gun, you can also apply some hot glue to the thermistor connector to ensure that it never pulls back out. While we're dealing with the wiring, this is also a good time to install the CR Touch or BL Touch wiring harness. In this build, I'm going with Creality's CR Touch, and so I'm going to take the CR Touch wiring harness, and I'm going to take the smaller connector, which is the connector that plugs into the CR Touch module, and I'm going to have to fish that through the wire sheathing for the printhead. The larger connector will plug directly into the main board, and you can see the receptacle right underneath of the thermistor connector that we just dealt with, and these connectors are keyed, so don't worry, you can't plug it in backwards. Then you can tidy up your wiring down here a little bit, but do not put the cover back on just yet because we're not done with the main board. We'll come back to this later. Now we can start some of the assembly work on the hot end and extruder, and in this video we're also going to be installing a CR Touch module from Creality. The CR Touch and the BL Touch are interchangeable, so it doesn't really matter which one you decide to go with. And to begin our assembly, we're going to take our Bondtech LGX Lite, and I'm showing it here in its assembled form. You can order it as an assembled kit, or as I showed you guys earlier in the video, it might come in 2 separate boxes if you order the extruder and the stepper motor separate from one another. The entire LGX Lite assembly is held together with these 2 long M3 socket head cap screws, and after you undo those, the motor can be removed from the back, and there's a small plate that can be removed from the middle of the assembly, and my 3D printed adapter will replace that plate. Then you can take your motor and put it back on top of the new plate, take your extruder, put it on the front of the plate, and reinstall the 2 long M3 socket head cap screws. And when you're done, it should look something like this. Now we can also start assembling the hot end and the hot end mount. So we're going to grab our Mosquito Magnum hot end and the hardware kit. In that hardware kit, you'll find a bunch of M2.5 screws. You'll also find some small washers for these small screws. We're going to be putting those washers on top of the M2.5 by 10 millimeter long socket head cap screws, and we're going to be inserting those into the 2 outer holes in the top of my Mosquito Magnum mounting bracket. I like to add a little bit of thread locker onto these screws because over time they can loosen and you don't want your hot end flopping around. The hot end should be a nice snug fit into the bottom of this bracket, and those 2 screws will draw it in and securely fasten it down. Now you don't have to go crazy here with the torque. You got to remember that these are small screws and this is a plastic mount that you're using. And plastic generally exhibits a pretty significant amount of creep over time. And mechanical creep is basically a time-dependent component of plastic deformation while that plastic is under load. And so one thing you have to watch out for is that over time, the plastic under the heads of the screws will deform and the screws will lose tension. Therefore, initially over-tightening these screws is not going to compensate for this inherent mechanical property of plastic. Rather, what I would recommend is going back and retightening these screws periodically until that plastic fully settles. Now we can prepare the CR Touch and its mounting bracket. The CR Touch comes with a few different types of hardware. We're going to be using this M3 by 6 button head cap screws. And on the 3D printed mount, you'll see a little cutout for the connector, and you should line up the CR Touch such that the connector is still accessible through that cutout in the mount. The M3 button head cap screws will get inserted through the bottom of the CR Touch, and they'll thread into the 3D printed bracket. And when you're done, it should look something like this. Now we're going to be installing the hot end subassembly that we just put together onto the X carriage bracket. And to do that, we're going to need 2 M3 by 10 socket head cap screws. Now in this video clip here, these screws that I'm showing are clearly longer than 10 millimeters, but I've since revised this part, so these screws that you would be using will be 10 millimeters long. And this hot end bracket will sit on top of the 2 standoffs on the X carriage bracket, and those 2 M3 screws will screw directly into those 2 standoffs. Next, we're going to install the piece of PTFE tubing that's going to go between the hot end and the extruder. I would highly recommend going with Capricorn tubing if you have access to it, and this piece is 47 millimeters long. Then we're going to grab 2 more M3x10 socket head cap screws and apply a little bit of Loctite. And these 2 here are going to fasten the extruder bracket to the X carriage bracket. The 2 M3 screws sit inside of the counterboard holes in the extruder bracket. And when you are installing this onto your X carriage bracket, you're first going to start by inserting the PTFE tube into the bottom of the Bondtech LGX Lite, and then those M3 screws should line up with the 2 holes on the X carriage bracket, and you can tighten those screws down. Looking at the back of the X carriage bracket, we're now going to install 2 3D printed reinforcement brackets. These 2 reinforcement pieces will hook over top of the back of the X carriage bracket, and then we're going to take 2 more M3x10 socket head cap screws, and those will get inserted into the counterboard holes inside of these 3D printed parts, and those screws will thread directly into the extruder mount. Back at the hot end, we're now going to remove the retaining screw from the right hand side of the heater block, and then we're going to insert our heater cartridge and thermistor. I've applied some of Slice Engineering's boron nitride thermal paste, and that's going to give us the best thermal conductivity between these components. Once these parts are inside of the heater block, you can now replace the retaining screw, and that's obviously going to prevent them from coming back out. Now we can start to position and route some of our wiring around the print head. So on the top right hand side of the extruder bracket, you'll find a strain relief. And on the left hand side of the print head, this is where the left hand side part cooling fan is going to go. And you can see that I've pulled away the PTFE tube. It's flexible enough to pull out of the extruder. And I've routed the left hand side part cooling fan wiring into a small wiring channel that I've designed into the extruder bracket, and then the part cooling fan will sit on the left hand side. Any excess wiring I'm going to try and push back up into the wire sheathing so I can roughly get the right amount of slack on these wires, so when the components sit in their final position, the wiring looks neat and tidy. And once I'm happy with the approximate amount of wiring that I'll need to complete the install, then I can take my zip ties and I can start to insert them through the strain relief. And if you just take the zip ties and push them through one side, they'll come right out the other side. And at this point, don't fully tighten down the zip ties, because once the fan shroud goes on, we're likely going to have to push and pull on those wires a little bit more. The fan shroud is next, and we're going to take the right hand side part cooling fan, and we're going to remove the wires from the strain relief that's part of the fan body. So you can see me pulling the wires out here, and the reason that we're doing this is that we're going to have to bend them back a little bit so that they can fit within the slot of the fan shroud. The radial part cooling fan will sit up against the side of the fan shroud, and there's a small raised lip that it will sit inside of that will hold it into place while you're screwing down the fan. Each part cooling fan will get fixed in place with these M2x8 thread forming screws, and there'll be 4 of them per fan. Then we can do more or less the same thing on the left hand side with the left hand part cooling fan, although we will not have to remove the wires from the fan's own strain relief. They'll just bend back nicely, and you'll see that I took the wires and I slipped it through the cutout in the fan shroud, and that's going to allow those wires to, of course, bend as you see them and then sit on the inside of the part cooling fan shroud. 4 more M2x8 thread forming screws will fix the left hand side part cooling fan in place. Next, we're going to mount the extruder fan inside of the fan shroud, and make sure that you're pointing it in the correct direction such that the airflow flows towards the extruder heatsink. And there are going to be 2 M3x22mm long socket head cap screws that fix the whole thing into place. You will have to move some wires around and bundle other wires together. I would just suggest trying not to push and pull too much on the more delicate wires of the thermistor, and any excess wiring you can push back up into the wiring harness. And once you get everything into place, those 2 M3x22mm socket head cap screws will thread into the standoffs of the hot end mount. Then we can continue to clean up the wiring, and you're going to make sure that the braided wire loom sits inside of the strain relief. So you want those zip ties that you're going to start to snug down a little bit to clamp down on the wire loom and not on the bare wires themselves. Then we can mount the CR Touch assembly, and I'm going to take the connector and plug it directly into the probe. And then from the CR Touch kit, there are two M3x8 button head cap screws that will fix this assembly to the X carriage bracket. And so the Creality X carriage bracket already comes with two holes off on the right hand side of this bracket where these screws will thread into. With all of the print head components in place, we now know that we have enough wire to reach all of these components. So what I like to do here is just pull down that braided wire loom a little bit more and place one more zip tie below the strain relief on the extruder bracket. This is really going to ensure that the connectors of the wires are never pulled on and nothing ever comes loose. And when you're done, everything should look like this at this point. Now we need to address the extruder motor wiring, and the LGX Lite comes with this 4-pin connector, and the original Creality harness has a 6-pin connector, and unfortunately both of them are female connectors. So what we need to do here is either splice them together directly, or in my case I decided to go with a wiring harness adapter, and I put two male JST connectors on both sides. Male JST connectors in the wire-to-wire variety are pretty hard to come by, so what I just did here was I took some board-to-wire connectors and I soldered my own wires onto the end of them. And I really want to reiterate here that you do not have to do this. You can simply just splice the two harnesses together, and the reason that I didn't run the LGX Lite wiring harness all the way down to the main board is that it doesn't quite reach on the Ender 3 Max. If I were you, I would just cut the two female connectors off and splice those wiring harnesses directly together. And if you ever needed to replace the motor, you could just cut and resplice because there's plenty of length on the LGX Lite wiring harness. And without yet having swapped any of the pins, right now pin 1 of the LGX connector is the red wire, and that's connected to pin 1 of the Creality harness, which is identified with that little tag with the E on it. According to the LDO motor datasheet, the wires red and green are part of the same coil, and then yellow and blue are part of the same coil. And if you line those up with the Creality harness, you'll find that the Creality harness goes from coil A, then B, then A negative to B negative. So we have to swap two of the pins on the LDO connector to make sure that the coils match with the wiring of the Creality harness. And if you've never done it, there are lots of videos on YouTube showing how to repin these JST connectors. And so you can see here that my wire order is now red, yellow, green, blue, and the red is connected to pin 1 on the Ender 3 Max harness. And again, pin 1 on the Creality harness is identified with that little yellow tag. I hope that wasn't too confusing, but now our extruder motor will turn in the correct direction. Now we can tidy up some of the small remaining loose ends, and this includes the PTFE tube from the X gantry all the way to the LGX Lite, and I'm going with the Capricorn tube here. Then what we can do is tidy up the wiring, and so we're going to be attaching the wiring of the LGX Lite to the main wiring harness, and then I'm going to be using some split loom to even further support the wiring harness from the printhead all the way to the X gantry. The braided split loom is really great stuff because then you don't have to fish wires through it. You can just wrap it around existing wiring harnesses. And you can see that I've cut the original zip ties on the strain relief on the printhead, and I've replaced them and brought that split loom down into the strain relief to provide even more support to the wiring harness. And if you recall from earlier in the video, we did not put the cover back on the main board because we now need to access this trim pot for the extruder stepper motor driver. And you can see that I have my probe from my multimeter, and we're going to be probing the center of this trim pot. But first I'm going to turn it slightly counterclockwise to bring the reference voltage down. And what we're shooting for here is about 0.9 volts. And if you've never done this before, I'm using the black ground probe, touching any ground point on the board. And in this case, I'm using the negative screw terminal from the input power coming into the board from the power supply. Do not turn the trim pot screw too much. Small adjustments will result in pretty big changes in the reference voltage. And by adjusting that reference voltage, what you have just done is limited the amount of current being delivered to that smaller pancake motor on the new LGX extruder. And finally, we're ready to tuck our wires back in and reinstall the main board cover. If you've installed an auto bed leveling probe, we now need to do a firmware update, and the firmware needs to match the version of the main board that we have. So in my case, I have the older 4.22 main board, and I've found a version of the firmware on Creality3dofficial.com. And this is a distributor of Creality products. This is not the actual official Creality website. And that's because, as you see here, on the official Creality website, you'll only find the auto bed leveling version of the firmware for the newer 4.2.7 version of the main board for the Ender 3 Max. Now, if you're asking why you can't find the auto bed leveling version of the firmware for the 4.2.2 version of the main board for the Ender 3 Max on the actual Creality website, that's when you're just gonna have to stop asking questions, because this is pretty much how Creality operates. And if you're not already familiar with their antics, well, here's your first foray into some of the weird things that they do. But as you can see, at least they have the 4.2.7 version of the firmware available, so you can get that from them. But if you guys are having a hard time finding this firmware in the future, visit my website, embracemaking.com, and under the product listing for this exact upgrade, I've got you guys covered because I've downloaded and made these files available on my website. So they'll never go down, and you'll always be able to find them there. Then you need a clean formatted 8GB micro SD card, and you're gonna take the firmware file that you downloaded, which should be a .bin file, and copy it onto the SD card. Now you can pop the SD card into the printer, and you're going to power it back on. In a few moments, you should see the Ender screen flash back up on the screen, and the firmware should have been updated. You can power cycle the printer again, and up until this point, if you've done everything correctly, you should see a purple looking light on your CR Touch module. Red lights are bad, purple is good. And if you really want to make sure the firmware was updated, you can go down into the About Printer, and you can see the firmware version. Before we can start printing, we need to take care of a few more things, and I've connected the printer to a print host, in this case Repetier host, and you can see that the printer has successfully connected. And then I'm going to go up to the G-code terminal and type in M503, and this is going to bring up all of the printer settings. I'm going to be looking for an M92 line, and you can see here it says E93, and that means I have 93 steps per millimeter right now for the extruder. We need to change that, so we're going to go M92 E562. To see if the printer successfully changed the E steps to 562, I'm going to type back in M503. I'm going to look for the new M92 line, and yes, it says E562. So we're going to save that by typing in M500. And if you're finding that it's not saving these commands, you might have to check to see if you left the SD card in the machine, because without the SD card, it won't save it. After that, we have to run a PID Autotune for the new hot end. So M303 initiates a PID Autotune. C8 just means that we're going to run through 8 cycles of testing. S210 means we're going to center the temperature around 210 degrees Celsius. And U1 indicates to the printer that you're going to write those new values to memory once the testing is complete. If you plan on running higher temperature materials, consider centering your PID Autotune around the print temperature of the material that you wish to run. The process should take a few minutes, and then you should be able to find a message that says PID Autotune finished, and you'll see the new values. And although we told the printer to use the new values immediately after finishing the PID Autotune, it's still not a bad idea to just make sure those values are saved in memory by typing in M500 one more time. And then immediately after that, you can type back in M503 to make sure the printer spits back the new values. So go ahead and look through all of that newly printed information, and on the line that says M301, you should see the new PID values that match the ones that you saw when the Autotune finished. Now that we have the proper PID settings for the hot end, I'm going to turn the nozzle temperature up to about 230 or 240 degrees and double check the tightness of the nozzle. If you guys are doing this, don't go too crazy. It's just a very small nozzle. It only needs to be lightly torqued. After that, I'm simply going to home the printer, because the next thing we're going to do is set the Z offset and level the print bed. But before we do that, I like to let the print bed heat soak. So I'm going to set the print bed temperature to 60 degrees Celsius, which is typically what I run for PLA. and I'm going to let the print bed sit for about 5 minutes at 60 degrees. In order to get the proper Z offset for the new auto bed leveling probe, I'm going to have to move the Z axis into the Z equals 0 position. You'll also see me temporarily disable the stepper motors here just because it's easier to move the print head around by hand. And I'm going to move that nozzle approximately to the middle of the print bed. And again, with the paper, you can see there's too much room between the nozzle and the print bed when the nozzle should be at Z equals 0. And now with the new firmware, you can see in the bed leveling area, there is a Z offset section. So when you head into that, you can adjust the Z offset into the more negative space, and that's going to bring the nozzle closer to the print bed. And using a piece of paper, you should feel a light drag between the nozzle and the print bed with the piece of paper in between. With the new probe offset established, I'm going to auto home the printer again and then tell it to go back to Z equals 0 so I can double check the position of the nozzle with respect to the print bed using the piece of paper method. What you might find is that you'll have to make some further adjustments to the Z probe offset, and this is what I had to do. I had a little too much space, but unfortunately with the Ender 3 Max firmware, you can only make adjustments in increments of 0.1 millimeters, which doesn't give you very fine resolution for the Z probe offset. However, what I found on other Creality machines, which I think is really odd, is that if you're making live adjustments, so while a print is actually going on, you can change things like the Z offset. And that is essentially the Z probe offset. And while you're doing it live, some Creality firmwares allow you to have a finer resolution while making live adjustments than while making adjustments like this, not during a print. And so once I'm happy with the offset, at least for now, I'm going to disable the stepper motors again because I'm going to manually move the print head around while I do the bed leveling with the bed leveling knobs. And I see this question come up all the time online. If I have an auto bed leveling sensor, why do I still need to level the bed using the bed leveling knobs? And the answer to that is that you want the printer to have to compensate as little as possible using the auto bed leveling system. Having your printer properly trammed right from the start will always yield better results than having the Z axis having to constantly move around to compensate for a poorly trammed printer. And finally, we're now ready to run the auto bed leveling. So in the bed leveling section, you can just hit level bed and the printer will go ahead and initiate the auto bed leveling process, whereby it should measure about 16 points across the print bed and save them into the printer's memory. Loading filament into your new extruder and hot end is extremely easy, and with the LGX Lite, what I like to do is remove the PTFE tube from the top of the extruder. Make sure that your hot end has been preheated to the proper temperature, and then what I like to do is push the filament in through the filament runout detection sensor through the PTFE tube, and then you can grab it by your hand and force it down through the hot end until you see it come out of the nozzle. Once you see filament coming out of the nozzle, you can push the tensioning lever over into the first position, and that's more than enough tension for PLA. Lastly, there are some changes that need to be made in your slicer. So in my case, I am running the CR Touch module. So I'm going to look for the last call to G28 in my start G code. And what I need to do here is insert M420S1. And what this is going to do, it's going to load in the last mesh, because a call to G28 disables the use of auto bed leveling. So we need to re-enable it by calling M420S1, and that's going to use the last mesh saved into memory. Then we can change some of the retraction parameters because we're no longer using a Bowden tube setup, but a direct drive, so we can reduce the retraction length to 1 millimeter. I'm also going to be enabling Z hopping, and this is definitely not necessary to do, but I do find I get cleaner PETG prints with it, so I'm going to put 0.2 millimeters in there for the Z hopping. And I'm going to save that under a Creality Ender 3 Max LGX version of this print profile in my Prusa Slicer software. Then after that, we can change the retraction speed and de-retraction speed. So from Bondtech, it is recommended to go with 35 millimeters per second in both of these fields. And for me on this machine, I'm going to be running a 0.6 millimeter nozzle. So I'm going to change the nozzle diameter up at the top to 0.6 millimeters. And then one thing I forgot to show in this video clip here is that I should also change the layer height limits because I'm using a larger nozzle diameter. So under the layer height limits, there's a maximum layer height setting, and I should change that to about 0.4 millimeters in my case. Now, if you've been 3D printing for a while, you've likely seen other videos outlining the advantages of running a larger nozzle. And so what I'm going to do here is I'm going to go through that, but then also show the advantage of having a better hot end with a larger volumetric flow rate capability. So right now I'm setting up my slicer with this part to have pretty much the default settings for the Ender 3 Max. I'm going to be running a 0.2 millimeter layer height and using all of the other default settings for PLA and the printer. And the only thing I've changed in the print settings was just to make sure that I had 3 horizontal layers and 3 layers on the top and bottom of the part. The infill setting I'm going to run at 15%, and when I go to slice this file, you'll see here that with the default settings, this very large part comes out to about 16.5 hours. In this case, most of that time is spent on the infill and perimeters and external perimeters, and that's because there's a lot of empty space in this hex pattern part. In terms of the volumetric flow rate, you can see here that I'm not reaching anything over about close to 5 cubic millimeters per second, and although the stock hot end is capable of doing more than that, I just want to show you with the default settings what kind of print times you would get. Now I'm going to swap some parameters over to settings that better suit the Ender 3 Max with the upgrades that we just performed. And so in the filament settings, I've changed the maximum volumetric flow rate to 20 cubic millimeters per second. And the Mosquito Magnum hot end should be able to do that with ease. When I performed this exact upgrade on my Ender 7 using the LGX Lite extruder combined with the Mosquito Magnum hot end, I ran some benchmark flow tests and I could easily hit 30 cubic millimeters per second. So this is pretty conservative. Now in the print settings, I'm going to change the layer height to 0.4 millimeters, and in the vertical shells, I can leave it at 2 instead of 3, and that's going to give me the same vertical shell thickness, because when we had a 0.4 millimeter nozzle, if I had 3 walls at 0.4 millimeters, that's a 1.2 millimeter wall thickness, and now I have 0.6 millimeter walls times 2. So I still am achieving a 1.2 millimeter wall thickness. And in this profile, I actually just slowed down my linear speeds to better match the default Creality profile that I just originally sliced with, just to show you guys that by simply changing the layer heights and not much else, we can reduce the print time from 16.5 hours all the way down to close to 7 hours. So 6 hours and about 45 minutes, and that's incredible. But wait, there's more. And that's because now with the higher capacity for volumetric flow, I can increase the linear speeds. With those previous speeds, you can see in the top left-hand corner right now, I was really only hitting about 15 cubic millimeters per second of maximum flow somewhere in the print, and that was likely in the infill. And so I switched print profiles yet again, and in this case, the perimeters are going to be set to 75 millimeters per second, the infill speed to 65. Pretty much all of the other parameters are the same. Infill density, I'll make sure is at 15%. And just to show you guys I'm not messing around with anything here, the layers are still 0.4, perimeters 2, and the horizontal shells at 3 at both top and bottom. So we'll slice again, and we'll find out if we've saved any more time. And in fact we have, so we've gone down now to about 5 hours and 15 minutes. Knocking another hour and a half off of this print from about 6 hours and 45 minutes is roughly about a 20% savings in time just by changing the linear speeds. And now I'm only up to a volumetric flow rate maximum of about 20 cubic millimeters per second. And the hot end definitely has more, but to be honest, at this time I have not spent enough time with the Ender 3 Max dialing in all of those little settings to optimize print quality along with speed. So for now, I'm just going to stop there so that we can get started printing, and the print quality should still be very acceptable. And so what I think you should take away from this very simple example is how effective the larger nozzle is, and then how much further you can push that larger nozzle with a much more capable hot end. With the regular Ender 3 Max hot end, you might be capped at, let's say, 10 or 12 cubic millimeters per second flow rate, and that's going to limit how fast you can print and how efficient you can use the larger build volume of the Ender 3 Max. Finally, the moment we've all been waiting for, and this is the very first print with the new upgrades. And so I have not sped up or slowed down this video clip, and you can see my first layer speeds are very conservative, and you can also tell this is the first print because that nozzle and heater block are still extremely clean. With the auto bed leveling sensor, I was able to print off a pretty large part, and the first layer went down super clean. The rest of the part was also very clean. However, I do have some tuning to do to try and get rid of that stringing. Since I'm running a larger nozzle with larger layer heights and faster speeds, I did bump up the print temperature about 10 degrees on this first part, and that's probably why I'm seeing a little bit of stringing. With the higher print temperature, obviously the filament flows a little bit better, but then you also get more stringing. So I'm gonna have to try and tune that out and work on this profile a little bit, but otherwise the part looks pretty good. Under some lighting, I can also see a little bit of pillowing on the top layers, which may also be a function of the higher print temperatures, and so I can probably rectify that with another top solid layer, or perhaps increasing the cooling a little bit on those top layers. Here are a few more parts that I printed in blue PLA, and it's a little easier to see the details of these prints against the black print bed. Everything turned out quite nice with these prints as well. I did drop the print temperature a little bit with these ones, so I did see less stringing. However, one other thing that I'm starting to notice here on some of these prints is that my top layer has a little bit of over extrusion now. So in Prusa Slicer, I don't believe that you can independently adjust the flow rate of just the top layer. I think you can do that in Cura. So I'm going to have to investigate why I'm seeing over extrusion in just the top layer, but the rest of the prints turned out very nice overall. And with those larger layer heights, I was saving a ton of time on each of these prints. Also, with the cooler print temperatures, you can see on this exact same part that I had printed previously in black, the blue part does not have that same pillowing on those top layers. So it turned out much better, and I didn't have to make any other adjustments or add any more top layers. Then I started swapping back to the black filament, and I printed one of these Flexi Rex articulated dinosaurs. And you can see the top layer still does have some over extrusion, and you can see where the nozzle has sort of dragged through that a little bit. But the walls came out quite nice and clean, even with the 0.4 millimeter layer resolution height. And those little features on the back of the dinosaur's spine also came out pretty nice. So the part cooling fan in that particular case seemed to be working just fine. None of the articulated joints fused together, so again with the 0.4 millimeter nozzle, this was not an issue. The bottom layer was super clean, as you would expect with the auto bed leveling feature. And then you can see on the very steep overhangs on his arms, I probably could use a little more cooling, but these are challenging to print when you're using large layer heights and large line widths. After that, I decided to switch over to some very attractive red PLA, and I started printing shells for a drill bit case that I designed, and you can find a link to that video in the top right hand corner of the screen right now. These shells turned out pretty nice looking, although I did see with the red PLA some of the pillowing coming back on the top solid layers, despite going with the lower print temperature again. By no means am I a filament expert or chemistry major, so I don't know the effect that color would have on the melting temperature of filaments even within the same brand, but I have noticed with some brands that this is the case. So I'm going to chalk this up as just slightly different properties with the red PLA than what I've seen with the blue PLA. Otherwise, this was another very nice print, and I had many more after that where I enjoyed the time savings with this new extruder and hot end setup. That's it for this video. If you guys are looking for more Ender 3 Max content, be sure to check out my channel because I've already done a few other videos on this printer and I plan on doing more. So if you don't want to miss the future content, then hit the subscribe button down below. And if you guys have any questions, put them in the comment section down below. If you guys are looking to support me and my work, check out my website, embracemaking.com. I offer all sorts of 3D printer upgrades, laser cutter upgrades, all of that sort of fun stuff to enhance your maker experience. Of course, you'll find the upgrade that you saw in this video today, and you'll find things like magnetic flex plates that actually fit the Ender 3 Max, unlike some stuff that you might find on Amazon or eBay. I've tried a few of those at the beginning and they did not fit, even though they were listed for that particular application. And I want to send one final big thank you out to Bondtech and Slice Engineering for their continued support with me and my channel. And this allows me to bring videos like this to you guys, so I highly recommend going to check out Bondtech and Slice Engineering. Thank you again for watching, and I hope to see you guys in the next video.